Very good morning to one and all. Today we have been seeing about the topic on turbo machines. Definition of a turbo machine. Turbines are the energy developing machines. Turbines convert fluid energy into the mechanical energy. The mechanical energy developed by the turbines is to running an electric generator which is directly connected to the shaft of the electric generator and can be easily converted into the mechanical energy. Earlier days, the turbine wheels are used wooden wheels. In that overshot wheels are used. It have very good efficiency. Could not handle the large quantity of water. Undershot wheels have low efficiency. The main application of the turbines are hydropower plants. The general layout of hydropower plant is reservoirs, dam, penstock. First of all, we have been seen about reservoir. Reservoirs ensure the supply of water throughout the year by storing water during rainy season and supplying the same during dry season. Dam. And the function of the dam is to increase the reservoir capacity and to increase the working head of the turbine. Penstock. A pipe between the dam and turbine is known as penstock. It will carry the water from the dam to turbine. Penstock is commonly made of steel pipes converted with RCC. Surge or forebay. When the rate of flow through the penstock is suddenly decreased, the pressure inside the penstock will increase suddenly due to water hammer and thereby damage the penstock. Surge tank is constructed between the dam and the turbine. It will act as the pressure regulator during the variable loads. Turbine. Turbines convert the kinetic and potential energy of water into mechanical energy to produce electric power. Generator. Electric generator converts mechanical energy into electrical energy. A step-up transformer will increase the voltage for loss-free transmission. This is the general layout of the hydropower plant. In that, river acts as the reservoir. The trash track is used for the gate, and the dam is constructed at the one side of the river. There will be the 4 by is attached like that. It is known as surge tank. The penstock is fitted between dam and the turbine. When the water is released from the dam with a high pressure, it will run in the penstock and reaches the turbine wheel. It will rotate, and that time the fluid energy will be converted into the mechanical energy. Advantages and disadvantages of hydropower plant. Advantages of hydraulic power plant. Operating cost is very low, less maintenance cost and less manpower required. Pollution free, quick to start and easy to synchronize. Can be used for irrigation and flood control. The plant life is very long. Disadvantages of hydropower plants. Initial cost of the total power plant is comparatively high when compared with other power plants. Power generation depends upon availability of water. Cost of transmission is high since most of the plants are in remote areas. Project duration is very long. Heads of hydraulic turbines. Cross head. First one. Difference between the head raise level and tail raise level. Static. Total head minus H1. Net or effective head. Head available at the entrance of the turbine H is equal to H1 minus HF. Net head for a reaction turbine H is equal to P1 by W plus V1 square by 2G plus Z1 minus Z2 plus V2 square by 2G. It is the Bernoulli equation principle. Net head of impulse turbine H is equal to P1 by W plus V1 square by 2G plus Z1 minus Z2. These are the equations come from the energy equation. Efficiency of the hydraulic turbines. Efficiency of the hydraulic turbine. Hydraulic efficiency. Due to the hydraulic losses, power developed by the runner, net power supplied at the turbine entrance. SI unit is kilowatt. Metric unit is horsepower by water horsepower. Mechanical efficiency. Due to mechanical losses, bearing friction. Power available at the turbine shaft divided by power developed by the runner. Volumetric efficiency. Due to the amount of water slips directly to the tail race. Amount of water shrinking the runner and by amount of water supplied to the turbine. Overall efficiency of the hydraulic power plant. Power available at the turbine shaft divided by net power supplied at the turbine entrance. This is the classification chart of the turbines. Impulse and reaction turbines mainly classified into. In that, impulse turbine is classified into Pelton, Turgo, Crossflow. Reaction turbine is classified into propeller, Francis, and Darius. Propeller file is further classified into fixed blade, Kaplan, tubular, and bulb. Impulse turbine. The pressure of a liquid does not change while flowing through the rotor of the machine. The impulse turbine pressure changes occur only in the nozzle of the machine. One of the examples is Pelton wheel turbine, reaction turbine. The pressure of liquid changes while it flows through the rotor of the machine. The change in fluid velocity and reduction in its pressure causes a reaction on the turbine blades. This is where from the name of the reaction turbine may be derived. Francis and Teflon turbines are category of the reaction turbine. Based on the working media, the turbine is classified into hydraulic turbine, steam turbine, gas turbine and wind turbine. Based on head, head is the elevation difference of reservoir water level and difference between the water level. High head turbine above 250 meter, example Pelton turbine. Medium head turbine 60 to 250 mm turbine, example Francis turbine. Low head turbine below 60 meter, Kaplan turbine. Based on the specific feed, turbines can be classified based on the specific feed. Specific feed is defined as the speed in RPM of geometrically similar turbine, which is identical in shape, dimension, blade angles, and gate openings with the actual turbine working under the unit head and developing unit power. Specific speed is used to compare the turbines and it is noted by Newton's second. Specific feed N by root P divided by H 5 power 4. Low specific feed is 8.5 to 30 rpm. Example Pelton turbine. Medium specific feed is 50 to 340 rpm. Example Francis turbine. High speed turbines 250 to 860. Example Kaplan turbine. Based on the deposition of turbine main shaft, A. Horizontal shaft, B. Vertical shaft. Next, based on the flow through the runner, radial flow, inward, outward, axial flow, Kaplan turbine, mixed flow, Francis turbine, tangential flow, Pelton turbine. These are the examples of the flow of the turbines. Next, we can see about the design of Pelton wheel turbine. It is a circular disc with a cup-shaped blades, buckets, water jet emerging from a nozzle, is tangential to the circumference of the wheel. The below diagram shows the schematic representation of the Pelton wheel turbine. Working principle of the Pelton turbine. Water jets emerging strikes the bucket at a splitter. Splitter is kept in the border of the turbine. Stream flow along the inner curve of the bucket and leave it in the direction opposite to that of incoming jet. The high pressure water can be obtained from any water body situated at some height or streams of water flowing down the hills. The change in momentum. Momentum means direction of the speed of water stream produces an impulse on the blades of the wheel of Pelton turbine. The impulse generates the torque and rotation in the shaft of Pelton turbine. Horizontal shaft, not more than 2 jets are used. Vertical shaft, larger number of jets are used. Iron or steel casing to prevent splashing of water and to lead the water to the tail race. That's all. Friends, thank you. We will see in the next class. Thank you.